Hi viewers, through this video we are going to discuss everything about a supernova explosion A to Z. So don't skip the video and support us for more similar videos. A supernova explosion is very powerful star explosion that release an immense amount of energy to the space. It is very destructive as well as the constructive event. Let us see how it is possible. First of all, if we want to simply say a supernova is an explosion of a large star which is at least 8 times as massive as our sun. When this star's core collapse, or when this star's other regions, the outer region collapse, the star loses its balance and it destroy at the and explode itself. This is what the supernova. This forms the large amounts of the energy to the sky. The part of the supernova may become later on as a neutron star or black hole, as well as it makes as a building blocks. It acts as a building blocks of the planets, stars, and even life. Our sun and our earth and ourselves are the result of actually a supernova explosion. Let us discuss this later. First of all, let us see what are the types of supernovas. Actually, there are 2 types. The first one is a type 1 supernova. The people actually don't know about it, the type 1. People usually talk about the type 2 only. Let me explain what is the type 1. The type 1 supernova is when a big white dwarf star reaches the Chandrasekhar limit. Chandrasekhar limit means a kind of astronomical unit that is discovered by the famous scientist, Indian scientist Chandrasekhar. So when the white dwarf star reaches the Chandrasekhar limit, that is about 1.4 times as massive as our sun, it triggers the carbon fusion explosion of that star, resulting the destruction of the star completely. This is the type 1A supernova explosion. I mean that the type 1A supernova explosion is when the white dwarf star reaches the Chandrasekhar limit, that is 1.4 times as massive as our sun. It triggers the carbon fusion explosion of that outer region of that star. So that star destroys itself completely. This is type 1A. There are other 2 subcategories also, type 1B and type 1C. In type 1B, the same thing occurs but in the different way. The star that is much larger than, at least 8 times larger than our sun, is always undergoing the nuclear fusion. All the stars are undergoing nuclear fusion. When such a star is undergoing the nuclear fusion, sometime the outer region of the outer layer or region of the star that is almost covered by the hydrogen will collapse, and it makes the explosion of the outer region. This is called the type 1B supernova. In type 1C, the outer region is collapse or explode with hydrogen as well as helium layers. So in type 1B, only the hydrogen involved. In type 1C, hydrogen as well as helium involves. These are the subcategories of type 1 supernova explosion. Type 1A means a white dwarf collapsing its outer region, as well as type 1B means a bigger star, much bigger star than our sun's outer region of hydrogen is collapsing and exploding. As well as type 1C, the hydrogen as well as helium's layers are collapsing and exploding. These categories are under type 1 supernova. Now let us discuss what is the type 2 supernova. This is usually known as supernova. This is only, most of the people think only this is the supernova explosion. No. But this is the type 2 supernova explosion. Let us discuss what is this. First of all, a star that is at least 8 times larger than our sun. As usual, this star also undergoing the nuclear fusion, a cycle of a process of converting the hydrogen atoms to the helium atoms each and every nanoseconds. As a byproduct, it produces the light source and heat source. So this process is for large stars may undergo up to few billion or many million years. Once the fuel source is completely finished, this process is come to end point, the core collapse. the core as well as the outer region of the particular star has the always fight. The gravity of the outer region always force inwards, as well as the core of the stars always force outwards, but there is a balance maintained until the nuclear fusion is going in the correct manner. But once the nuclear fusion is over, that means that the star's stock of hydrogen atoms are over, the core wins. So the core of the star collapses with the heavier elements as well as releasing the greater energy to the space. This is what the type 2 supernova. There are many subcategories of the type 2, but all these categories are almost similar, named type 2P, type 2L, type 2N, type 2B. But whatever these subcategories are, the type 2 supernova is when the core of a massive star that is at least 8 times massive than our sun is collapsing, its core is collapsing and exploding to the sky. So type 1 means the outer layer of the star, of a white dwarf star or massive star, is when collapse with the carbon fusion or hydrogen or helium layer fusion. But type 2 is the core of the star is collapse with the outer region, releasing the larger amount of energy. So type 2 supernova are actually so powerful than type 1. Now let us discuss what causes this supernova. Actually all the stars, it may be like our sun or smaller than sun or 100 times larger than our sun, all the stars are undergoing a process called nuclear fusion, which is what is converting 2 hydrogen atoms into helium atoms that release the heat as well as light energy as a byproduct. So this process for the largest stars is only few millions or few billion years, but smaller stars for many trillion years. For our sun, this process will be undergoing up to 9 billion years. After that, since the size of our sun is not much bigger, it won't become as a supernova. It just become a white dwarf and ending its life as a dark star at the end. But the largest stars, they become the supernova. Okay, when the process of this nuclear fusion is over, the first in type 1, when the nuclear fusion is over, due to the collapse of the gravity, the outer region collapse. So it destroy the entire star and releasing the energy. This is type 1. In type 2, the core of the star is winning with the fight with the outer region, and it is making the great explosion, releasing the large amount of the energy to the sky. This is type 2 star supernova explosion. Now let us discuss what are the stages. First of all, the first stage is the fusion run out. It means the nuclear fusion stops. That is the first stage. When the nuclear fusion stops, the core collapses. The shock waves and explosion occurs. So this is resulting the larger amount of the energy trigger to the sky, to the space. Aftermath. After the explosion of this supernova, what will happen? There would be 2 results. One is the nuclear neutron star, another one is a black hole. If the star is just 8 times to our sun, it become a neutron star. The neutron star is very small but very powerful star. But if the star is up to 30 times larger than our sun, it become the black hole. The black hole is actually area or space and time that has the very unique laws of physics. So after either becoming a neutron star or black hole, the remnant of the supernova are becoming as the stellar nurseries. The stellar nurseries are stellar nurseries are responsible for the birth of new stars and new planets. So the supernova explosion is responsible for the creation of the neutron star or black hole, as well as the remnant of that supernova will lead for other stars birth and birth of other planets. The Crab Nebula is one of the good example for the remnant of this supernova explosion occurred in 1054. Now let us discuss what are the very famous supernova explosion ever recorded. The first one is SN 1054. That is actually the Crab Nebula that we are seeing in our Milky Way galaxy. This was recorded by the Chinese astronomers that occurred in 1054 AD. The second very popular supernova explosion recording was SN 1604 or Kepler's supernova. That was recorded by the famous astronomer Johannes Kepler in 1604. So this is named the Kepler's supernova. The very recent recorded supernova explosion was not occurred in our Milky Way galaxy but in our large Magellanic Cloud galaxy, which is the satellite, one of the satellite galaxies of our Milky Way. So this was recorded in 1987. So it was named SN 1987A. This is the latest recorded supernova explosion in the history of the astronomy. Now let us finally see about any possibilities of dangers by the supernova explosion to our Earth and solar system. Actually, the closest supernova that might have occurred or it will be occurring within another 100,000 years is Betelgeuse. The Betelgeuse star, the red giant Betelgeuse star, is located about 650 light years from our Earth and Sun. So even though this supernova has already occurred and still we didn't reach the light source of this supernova, there won't be any harm to our Earth because of this larger distance. But scientists says that if the supernova explosion occurs within the 50 light years to the Earth, definitely it will make the great damage to our Earth and even our Sun. But fortunately, there is no star that is able to become as a supernova within 50 light years from our Earth and Sun. So we are lucky enough and we are protected from the danger of the supernova explosion. So the closest supernova that is going to occur or might have occurred and light is not reached is Betelgeuse, located about 650 light years from our Earth. So through this video we have brought you many details about supernova. What is supernova, what are the types of supernovas, and what would be the danger of the supernovas, whether any danger will be occurring to our Earths, and what are the famous types of recorded supernovas. So finally, we have to say that the supernova is not only destructive, it is a constructive, because the supernova actually shapes the galaxy and shapes the universe also, and the supernova is the building blocks for the new stars and new planets. Actually, as we said earlier, our Earth and ourselves, our Sun, our entire solar system is born from a remnant of a supernova explosion. So supernova explosion is the greatest destructive event of this universe, as well as it is the constructive event too. So please join with us these kind of astronomical, motivational, and as well as the physics related videos. Please support and subscribe our channel. Thank you for watching.